14.6 Wrap-up. This chapter presented one of C++'s most powerful features, templates. You learned how to use function templates to enable the compiler to produce a set of function template specialization that represent a group of related overloaded functions. We also discussed how to overload a function template to create a specialized version of a function that handles a particular data type's processing in a manner that differs from the other function template specializations. Next, you learned about class templates and class template specializations. You saw examples of how to use a class template to create a group of related types that each perform identical processing on different data types. In the next chapter, we discuss many of C++'s I/O capabilities and demonstrate several stream manipulators that perform various formatting tasks. Summary. Section 14.1 Introduction. Templates, page 580, enable us to specify a range of related, overloaded functions called function template specializations or a range of related classes called class template specializations. Section 14.2 Function templates. To use function template specializations, page 580, you write a single function template definition, page 581. Based on the argument types provided in calls to this function, C++ generates separate specializations to handle each type of call appropriately. All function template definitions begin with the keyword template, page 581, followed by template parameters, page 581, enclosed in angle brackets, and each template parameter that represents a type must be preceded by keyword class or type name, page 581. Keywords type name and class used to specify function template parameters mean any fundamental type or user-defined type. Template definition template parameters are used to specify the kinds of arguments to the function, the return type of the function, and to declare variables in the function. As with function parameters, the names of template parameters must be unique inside a template definition. Template parameter names need not be unique across different function templates. Section 14.3 Overloading function templates. A function template may be overloaded, page 583, in several ways. We can provide other function templates that specify the same function name but different function parameters. A function template can also be overloaded by providing other non-template functions with the same function name but different function parameters. If both the template and non-template versions match a call, the non-template version will be used. Section 14.4 Class templates. Class templates provide the means for describing a class generically and for instantiating classes that are type-specific versions of this generic class. Class templates are called parameterized types, page 584. They require type parameters to specify how to customize a generic class template to form a specific class template specialization. To use class template specializations, you write one class template. When you need a new type-specific class, the compiler writes the source code for the class template specialization. A class template definition, page 584, looks like a conventional class definition, but it's preceded by template typename T, or template class T, to indicate this is a class template definition. Type parameter T acts as a placeholder for the type of the class to create. The type T is mentioned throughout the class definition and member function definitions as a generic type name. Member function definitions outside a class template each begin with template typename T, or template class T. Then, each function definition resembles a conventional function definition, except that the generic data in the class always is listed generically as type parameter T. The binary scope resolution operator is used with the class template name to tie each member function definition to the class template scope. Section 14.5 Non-type parameters and default types for class templates. It's specifiable to a non-type parameters, page 590, in the header of a class or function template. You can specify a default type, page 591, for a type parameter in the type parameter list. An explicit specialization, page 591, of a class template overrides a class template for a specific type.